For this video, we'll be continuing with 2017 paper. Okay, the question is this. We last stopped at here. State what is meant by an electric field. Is this in our syllabus this year? Yes, right. So you need to know the definition. And for us, we actually have three kind of fields. We have gravitational potential field. Sorry, not gravitational potential. Gravitational field. We have magnetic field, and we also have electric field. So you can actually memorize one of it, and you tweak it such that you don't need to memorize for all three, right? So what is electric field? It is a region. Can we reuse this word for magnetic field and gravitational field? We can, right? In which a charge. So this electric field actually acts on a charge, right? But for gravitational field, we have to tweak it. We have to change it to mass, right? A mass. For magnetic field will be magnetic, not just magnet, a magnetic material. So like that, you just need to change it and you just have a buy one get two free definition. Okay? So in which a charge for electric field, in which a mass for gravitational field, and magnetic material for magnetic field. And then the next thing that you need to change is your kind of force. So gravitational force, magnetic force. Okay? So please use this to help you memorize lesson stuff. Okay, what is incorrect in the Marcus report say that some did not specify that it was a charged object that experiences the force, and some stated that the object or force could experience a change in the electric field. Okay, there were also a number of wrong references to electromagnetism and to currents. Okay, so just keep it simple. How about the drawing? I don't think it's in our syllabus, right? It is, huh? Okay, so if it's in our syllabus, so if it's positive, right? If someone is very positive, they will sort of radiate their fields, isn't it? If someone is very positive, yes. But if someone is negative, then you think someone negative sort of sucking in all your energy, so it will be going into. What else can they ask about the electric field? They will ask you why electric field is in such a direction. Is in such a direction. So why is it that negative the arrows go in, positive the arrows go out? Did I tell you all the reason why? Because of the this one you need to write down, because of the direction of the electric field because of the direction of the electric force exerted on a small positive test charge. Okay, so why is the electric field in such a direction? It is because of the direction of the electric force exerted on a small positive test charge. Meaning, if let's say this is an unknown charge, and I use a positive test charge. And if this positive test charge moves in, the force is going into this unknown charge, right? What do you think is this unknown charge? It's going to be negative because unlike charges, attract. Now I have another unknown charge. Again, I use a small positive test charge. And this small positive test charge is now moving away. So what do you think is this unknown unknown charge? It must be positive because like charges repel. So why don't they use a negative test charge? Because that day the scientists were feeling a bit more positive. Wow! Here, why is the direction like that? Because it's not X. Because it's as if I have a positive charge here. It's as if I have a positive charge. I'm testing it. Then I find that the positive charge gets attracted to the negative charge because unlike charges attract, right? So the direction of the force is towards this negative point charge. Any question? The line must touch the circle. The line must touch the circle. Okay? And the lines cannot cross each other. And you cannot have things like, this is wrong, huh? You cannot have things like that. You are not drawing a stick figure. Okay? You must make it evenly distributed. Evenly distributed. And you must make sure that the lines do not cut each other. Okay? If you look at the question, they say draw lines to show the shape and direction of the electric field. So direction, you need to draw in your arrow. So 1 mark for direction, 1 mark for the shape. If you draw weird shape but your direction is correct, you get 1 mark. Your shape is wrong. Yes, it must be evenly distributed. But what if it is like that? What if it's like that? I have two isolated charges. How do we draw in the shape of this electric field? Positive to negative, right? Then over here, my arrow wrong, right? Wow, very good. You're good at catching people's mistake, The more lines that you draw, some people go excessive, the higher the chance of making mistake. So don't overdraw. Don't overdraw. Just draw to show the correct pattern. You know, some people they will go like, okay. But then the more lines that you draw, the more mistakes you make. Just draw it sufficiently such that you can show the pattern. Like what is on the positive, the negative one is over, and that will cause you to result in a few arrows getting in the wrong direction. Then you have marked the pattern. Right? So this is for the drawing. Any questions before I continue? Okay. Then this one, have your underlined and annotated. What is this? What letter? V connected to a lamp. The lamp is switched on for 5 minutes. T, any trap for this? Y. Yeah, minute. So as you are reading, you must have this awareness. 5 times 60 equals to 300 seconds. Then what is this? I. Calculate for the time that the lamp is switched on. It was switched on for 300 seconds. The charge. Charge is what letter? Q. So then you can put in the correct formula. Okay. So will be 2.5 times 300. Okay. So answer will be 750 coulombs. Was the coulombs given to your? Yes, the units. C given, Next. They want us to calculate the energy. Energy is E. So if you have forgotten the formula, go back to the basic of energy equals to power times time. Yes, and I have I have V, I have T. So power equals to IVT. Then you just substitute everything in. Make sure if it's in joules, everything must be in SI unit. When do we calculate energy not in SI unit? When? When you see money. When you see money, you calculate your energy in kWh. So it's very obvious. You see money, it must be kWh. That means your timing must change to hours. Your power must change to kW. When you see the units mentioned, joules, it must everything be in SI unit. Okay, so the answer for this will be 4,500 joules. Okay, then we go to section B. Okay, what do you see from the first statement? Radiant heater. Radiant heater. Copper. Copper, what does it mean? What do you think of? Metal. Metal, what do you think of? Conduction. Conduction, what do you think of? Free electrons, diffusion, plus molecular vibrations. These are the things the first statement will have already tell you how to answer. So you must be very aware of this. Correct? So they are placed equal distance from a radiant heater. That means this heater is going to give out thermal energy in the form of infrared. Then you look at can A and can B. One is silver. The other one is dull black. What do you think of? Radiation. Alright, even before we look at what they are going to ask us, this must be, you must know this. They have the same mass, so they keep everything the same. Same shape, same size. Can A is painted silver, B is painted dull black. They emphasize this again. So you will later need your radiation concept. They contain equal masses of solid wax. When the heater is switched on, thermal energy from the heater reaches the solid wax by means of radiation. They tell you this. Okay? Through the air, that means they have air in between. When you see the word air, what do you think of? What do you think of? Air. What do you think of? Convection. Convection. There's possibility of convection because air is a fluid. What else? Radiation. No? Conduction. Why conduction? Poor conductor. It's a poor conductor. So when you see air, you must recognize that it can either be a poor conductor or there's a chance of convection current being formed. Right? And by conduction through the walls. Now, what is the can made of? What's the can made of? What material? Copper. So will it be a good conductor? Compared to a plastic, will the wax melt faster? Compared to a plastic container, a metal container and a plastic container, will the wax in the container melt faster in copper or in plastic? Copper. So these are the things that you must have. Right? Describe how thermal energy passes through the walls. Through the walls. So do I need to explain a lot about infrared radiation? I need to talk about through the wall. And what is the wall made up of? Metal, which is copper, which is a good conductor. So what are the two processes that you need to talk about? Convection and conduction. Molecular vibration and free electron diffusion. Do I need to talk about convection? Not yet, because they are talking about through the walls. Okay, so how many marks is that? 2 marks. So just nice. Electron diffusion plus molecular vibration. Let's look at the answer. I may be wrong. Okay, more energetic copper atoms vibrate more vigorously. They didn't even ask you to write about radiation. They didn't even ask you to write about the convection in air that is formed before that. They want through the wall. And they like to ask this kind of question. Okay, so be very specific. Look at the marks, 2 marks, so 2 processes. Vibrate more vigorously, that is a keyword. Use vibrate only for solid particles. More vigorously as a gain Ke, or as thermal energy is transferred to the energy in the kinetic store. Okay, so they are also looking out for the transfer energy. Because now energy we can't just anyhow use. They collide with neighboring atoms or particles and transfer their kinetic energy inside okay to the neighboring less energetic copper atoms. So that is how the energy is being transferred. Okay, so look at the markers report incorrect. Some cities stated that the thermal energy is conducted through the can. So just by saying that it is by conduction, you won't get the mark. Which added nothing to what was in the STEM question. Others contradicted the question by describing radiation through the wall. We don't do that. Okay? And I will upload this answer on Google Classroom. All of you are in there. Let's look at this. Now, explain why thermal energy cannot be conducted effectively through the air. Because air is a poor conductor between the radiant, heater, and the can. So the answer looks like this. Air is a poor conductor. Basically, if you say this, your 1 mark is there already. Then you can add on more to say that air particles are far apart from one another. Okay, and it's in constant random motion. Therefore, they collide with one another less frequently. So that's why I say, oh, basically you write air is a poor conductor of thermal energy. You should get 1 mark, but obviously not. They are looking for something more. You read the markers report. They say only a few candidates give a reason why air is a bad conductor. Only a few candidates. So is it good to explain why air is a bad conductor? But out of the whole cohort that year, only a few said that. So they are raising the stake, they are raising the bar higher. So in your last exam, can you write explicitly if you know the facts? Okay? Yeah, so this is important. Let's look at this. It shows the variation with time of the temperature of the wax in can B. Can B. I hope you all have underlined can B. So draw a graph to show how the temperature in can A changes with time. Now, can B is dull black. Can A is silver. Right? So did they start with the same temperature? Yes, right. So you must start at the same point. If you raise it higher or lower, straight away wrong. Okay? Then, what do you think is happening here? What do you think is happening here? Change of state, right? Because the temperature did not change. Right? Whenever temperature remains constant, there must be a change of state. Okay? Whenever temperature increase, there's no change in state. They cannot be together. So over here, it is a change in state. Will can A also, the wax in can A, will it also experience a change in state? It must. So let's look at the answer. Anything to talk about here? How? Yes, for this straight line, right? Will the timing taken for the wax to melt be the same in both can A and can B? Will it be the same? Why not? Why would it be the same? Because they are made of different material, they absorb or emit thermal energy. Which one? They absorb thermal energy. For the silver one, it absorbs at a lower rate. So less thermal energy is being absorbed. Therefore, it will take a longer time to melt. will take a longer time to melt it. No need. Basically, what you need to be having the same as this answer is the melting point. You must be the same. The timing cannot be the same. Cannot be shorter. It must be longer. Huh? Sorry? Why is the because it's the same material. If not, then I use different saucepan to heat water, to boil water, then boiling point same right? So now what is common between these two valves is that the melting point must be the same. Cannot be higher, cannot be lower, because it's the same wax. Okay? But the timing taken for A to melt is longer, not because of the volume. The volume was the same. Volume of wax is the same, but because the amount of thermal energy absorbed by can A, right, is the rate of absorption is lesser. Agree so far? Then after that, it will increase. Which thing? Here or here Okay, I think maybe the teacher just use a straight line. It can be a curve as well. Okay, yes. Is that one mark? Let's take a look. Total how many marks is this? 2 marks, right? So 1 mark will be for the slope area, I'm guessing. Slope area, you must show that it absorbs at a lower rate. The temperature didn't increase as much as the black one. The other one will be for the flat area, flat line. Let's read the markers report. Many candidates drew a line with a lower gradient when a solid but parallel to can B's line as a liquid. Parallel, meaning not at the same melting point. Correct? Parallel means not exactly the same. A small as a liquid. So over here is liquid already. So over here they drew parallel. That means the rate of increase in temperature is the same. This is what they are saying, and this is incorrect. It should be a lower gradient. Okay? Small minority show that the time will be reduced. A large minority drew the horizontal line at a different temperature. That means it's a different melting point, which is wrong. Or drew a horizontal line of similar length, which is wrong again. So do you know how to mark? Basically, the gradient, the slope, the sloping line must be lower. For the length that is a constant at horizontal line, it should be longer. Okay, and at the same temperature. Explain any differences between the shape. So you must talk about this. The heating curve for A is gentler than that of B because silver is a poorer absorber. Did you all get the concept correct? Yes. Did you all write because it's a poor absorber and emitter? If you wrote poor absorber and emitter, wrong. Because what's the context here? The cans are they absorbing or emitting? Absorbing. How to know whether it's absorbing or emitting? What question do you ask? Where is it hotter? Where is it hotter? Right? The wax in the can, is it hotter than the heater? No. So the heater will be giving out. The heater emits, the wax absorbs. The can absorbs. Is that you, Carlos? Describe the differences in terms of emission of radiation. Cannot, this is wrong. Some candidates stated that silver are poor conductors. This is super wrong. This is where I see a lot of people make mistakes. They always say black is a good conductor, black is a poor conductor. A sizable minority simply describe rather than explain. The question was that they asked you to explain, they didn't ask you to describe. So you must go down to the reason why. Okay. Okay, very good question. What if you just write as poor? Now, is there a comparison element here? So what must you use? Terms that terms to show comparison. Sometimes I forget as well. So whenever they have two scenarios side by side and ask you to compare, you must use comparative terms. Okay? Now describe how the motion and arrangement. This one is simple. I've tested you all many times. And it's 4 marks. But the way that you present must be careful. Do you all want to talk about motion first? Or do you want to talk about arrangement first? Do you want to talk about the solid motion and arrangement or the liquid arrangement and motion? So you have to be very clear, because if they don't see how it changes, right, then you don't get a mark. Okay, below the melting point, the molecules are in regular arrangement, so they are the solid and they vibrate in their fixed position. As temperature increases, molecules in the solid wax vibrate more vigorously, and this is still your only 1 mark. Then after that, at melting point, regular arrangement breaks down and the particles move further apart. Above melting point, molecules do not have a regular arrangement. They move in random directions, sliding past one another. So you need to be very detailed in your description about the motion and the arrangement as it melts, as it turns from solid to liquid. Okay? So what else do you think they can ask about this? They can bring in your internal energy. What happens to the internal energy? Right? In solid, the internal energy is lower, right? It consists of potential energy and kinetic energy. So as I'm heating the solid, which energy increases? The internal kinetic energy. The potential energy remains constant. Therefore, okay, so I think for particles, right, when we are talking about particles, we no longer use store. Wait. For store, we use it for object. Like this table, we have to use store. But how about the particles in this table? We just use energy. So, I mean, if you look at it, table is a store of particles. They have a lot of particles. So, they will have internal store for this table itself. But for particle, they are just by themselves. So, they either have Ke or Pe, and their sum of it is the internal energy. So, we don't use store for the particles. And so, solid, as I heat up, the kinetic energy increase, potential energy remains constant. As it's melting, what happens to the kinetic energy? Remains constant, the potential energy increases. Okay? Then when it's liquid, I heat it up, the kinetic energy increases, potential energy remains constant until it starts to boil. Okay, teacher and the student carry out an experiment to measure time taken for sound to travel through air. I think, I don't know whether is it your or the pure classes, but sometimes they will ask you to conduct an experiment to find out what is the speed of sound. So it is something like that. Okay? Teacher stands in an open space, the student holds a stopwatch, stands a distance of 100 meters. The teacher raises his arm and blows the whistle at the same time. So raise arm and blow whistle. The student starts a stopwatch when she sees the arm being raised and stop the stopwatch when she first hears the whistle. This is given speed of sound in air. Calculate the time taken for the sound to travel from the teacher to the student. Like that, 2 marks. distance over speed is equal to time. So we get 0.303 seconds. Make sure 3 accept. Next, explain why the time recorded by the student is very likely to be inaccurate. Do you know why? Not really human reaction.
Assuming the time of true light is instantaneous.
Okay, so basically, when you see something and when you hear something, the time is different. Because the speed of light is how many times more than the speed of sound? About 10,000 times more. What is the speed of sound? Speed of sound is 330 meter per second. Speed of light is, so it is many times faster than the speed of sound, right? So the distance between the teacher and the student is too short. So the student may see the teacher raise hand and hear the sound almost at the same time, because the distance between the teacher and the student is, the distance is too short. Right? Sometimes you see lightning. You see lightning. A few seconds later, then you hear the thunder. Why? Because the speed of light is faster. You see it first, then the speed of sound slower. You hear the sound at a much later time. It's not because your eyes are in front and your ears are behind. Okay? So over here, you need to also mention speed of light is much faster than speed of sound. Because for 3 marks, I don't think it's such a like 2 statement or even 1 statement. Okay, you need to talk about speed of light is much faster than speed of sound. I don't think it's here. Okay, but the Marcus report say many students did not mention the significance of the time measured being similar to reaction time. Okay, please write down the speed of light much faster. Now, next, they do an experiment to compare the time taken for the sound to travel through rock and through air. Rock is what kind of substance? Solid. Air leh? Yes. How are the particles in the air arranged? Far apart, randomly moving. How about in solid? Close together, right? And in fixed position. So, very lengthy. Distance between the explosive and the student is now 1 km. When the explosive is set off, each student starts the timer when she sees the flash and stops the timer when she hears the bang. Will there be a time difference? Hello, will there be a time difference? Yes, right, because now the distance is 1 km, 10 times more. So student A detects a sound that travels through the rock by putting her ear against a post that is stuck into the surface of the rock. Student B detects a sound that has traveled through the air. Who will hear the sound first? A or B?
A.
So it will have to come down to here. Solid particles are close together. Is it easier for the sound energy to be transmitted through these solid particles? Yes, because they are closer together and they are in a fixed position. But in the air or gas, they are far apart. Right? So and they are randomly moving. So it's very difficult to pass from one particle to the next particle. Okay? So, but they didn't ask for this. They want this first. And this is an answer that you can memorize. How is sound traveling through the air? So what are the keywords that you need to have? It's a longitudinal wave. What else? It vibrates the air around it. Okay, so I know I always say solid particles vibrate, but over here you can say it vibrates the air particles around it. Okay, air particles, and then creates a series of compression and rarefaction, right? And this transfers the energy, the sound energy, through collision. So the air particles will collide with their neighboring particles. So let's look at the answer. But generally, these are the things that when you see sound question, these are the concepts that you must know. It's longitudinal. By the way, longitudinal, what direction do you think of? Parallel. Okay, let's look at the answer. So longitudinal, vibrate, compression and refraction, transfer the sound energy through collision. Vibrate to and fro, parallel to the direction of wave travel. Compression and rarefaction, transmitted as a longitudinal wave without the transfer of air particles. Whack everything in, throw the whole kitchen sink in, okay, to get your full mark. Right? And in my notes, the one that compiled have many examples. Okay, so these are something that you must memorize. All right. Common misconception that particles travel to the observer. That is why they want you to write this without the transfer of the air particles. So there will be some students say, oh, the air particle from the explosion travel to the listeners here. No, it doesn't. Okay? A small minority confuse longitudinal waves and transverse waves. So these are things that you should avoid. Okay, I'll upload the answers. Then why student A less than the time measured by the student B? With reference, when you see by reference, you must refer to them. Okay, to molecules in the rock and in the air, why the times are different? So let's take a look. Air molecules are far apart, rock are packed close together. The transfer of vibrational energy from one molecule to the next is less efficient in air than in the rock. Both sound travel the same distance. Okay, they did not ask the rock, the sound in rock to travel longer, right? But the sound traveling through the rock took lesser time. Therefore, sound travels slower in the air than in the rock. Okay, you must account for the speed. You must make reference to the particles in the medium. Okay, then do we still have time for the last one? Quickly, okay. Can. Okay, so this one, when you look at this kind of question, what does it look like? Energy, GPE, transfer, right? So we have pump, we have lake, we have height. So this is our first thing that you need to underline is height. The pump raises water from the lake to the upper reservoir at a rate of this. Then you look at it, what is 3 kg, 3 times 10 to the power 6 kg per minute. Nothing confusing. It's just every minute, what is the mass? 3 times 10 to the power 6. Right? That means in 1 second, how much is it? What's the mass? 3 times 10 to the power 6 divided by 60. Why? Because I know energy is SI unit. So I'm just guarding myself in case later they ask for the energy calculate. So I need to change it to seconds, which is SI unit. So this one maybe you need to take note. This one not in SI unit. And they mention again that the height is 520. Calculate the useful power output when raising the water. They give us G. So what is the mass of water per unit time? See, need to change it to seconds. Because SI unit, everything in energy is SI unit. So power equals to mgh, right? Which is the energy over time. And we have time already. Because this is 50,000 kg per second. So we have our time at our bottom. That is 1 second, I will have this amount of mass. Then I have my G, I have my H. Okay, so that's for 12A. Shall we look at 12B? 12B. Input energy to the pump is electrical energy. State the measurement that will be needed to measure the power. Now, power what formula? IB, right? Because now we switch to electrical. Just now was MPH. Now we switch to electrical energy. So we need I and B. And how do we measure I and B? Connect ammeter in series to measure the current. Voltmeter parallel. So this one is series and parallel for voltmeter and ammeter. Then after that we have our IB. We can use that to calculate our power. Incorrect. Majority is how to measure output power by determining the energy gain in raising the water and dividing by the time. So, okay, if you look at the question, they say measurements that will be determined, they already tell you must be in terms of electrical energy. Okay, at times of peak demand, water flows down from the upper reservoir to the lake through a turbine. Turbine drives a generator to produce electrical energy that's used at home. For every 100 watts that's used to pump energy, 75 watts is produced by the generator. What happens to the remainder? How come 100 watts then only use 75 watts? 2 marks.
Transfer to other stores such as sound and internal stores.
So this answer hasn't been updated to the stores one.
Yep.
Okay, but the idea is the same. Energy has been converted to, cannot use convert, must be transfer, right? Due to work done against friction, this one stays in the mechanical parts of the pump and the turbine. So they no longer just want, oh, got friction, got friction. You must sort of be able to identify where is the friction occurring. Okay? So if it's a turbine, it's something like your fan, got moving parts. So just say, oh, mechanical parts, the moving parts. Okay? Yeah. Some candidates suggested that energy is lost and thermal energy of sound, and that the water has a certain amount of residual kinetic energy as it reaches. So this one incorrect. So just take note.
Energy is released to the environment through those straws.
Yeah, can. Okay, so now last one, electric motor. Simplified. It shows the direction of current, so you should draw your current here as well. Right. Yeah. So when current flows, what happens? When current flows,
magnetic field.
It produces a magnetic field. And when the magnetic field is placed in an external magnet, then there will be a force. Yeah. Okay, so these are things that you should see. It's free to rotate by considering the direction. Explain why there's a turning effect. Okay, so I'll just show you the answer. So first part, current flow produces a magnetic field. Same thing, right? And then it interacts with the external magnetic field. So you must acknowledge that there's an external magnetic field. Because when current flow, it produces a magnetic field. If there's no external magnetic field, no force. How do we determine the direction of the magnetic field produced by the current? Left hand or right hand? Right hand grip. Right hand grip. After that, how do we determine the direction of the force? Fleming left hand. When do you use Fleming left hand? When you see that there's an external magnetic field. Don't every time you see current flow got magnet, then straight away left hand up. Okay? Must determine that there is external magnetic field. So then, using Fleming left hand cannot be used to explain why there's a force. Fleming left hand is only there to predict the direction of the force. But what causes a force? It is due to the interactions of the magnetic field. The magnetic field produced by the current interact with the magnetic field of the external magnet. They interact to produce a force. Fleming left hand just to predict. So once I use Fleming left hand to predict, I can say that CD is upwards, AB is downwards. Then they produce a turning effect because they are on opposite side of the coil. Okay? But opposite direction, so same. Yay!